Alright, redo this time with audio. As I was saying before in the other video, I can pull any nitrogen cycle image. There's just a couple things that you should be comfortable with by now. I will try to break it down one last time. I'm not going to pull a specific image. There's just some very general things you should be comfortable with at this point in time. I will try to relate it back to your diagram with some of the other diagrams you can run across on the internet. Really, I can pull from just about any of these, but again, you should just be comfortable working with any of them. Like I said, I'll do my best to try to break it down bit by bit. So first off, atmospheric nitrogen, N2. It can be broken down in a couple of different ways. It can be broken down in the soil by what we call nitrogen-fixing bacteria that converts it into ammonium or ammonia. There's also some on plant roots that will convert it from atmospheric nitrogen into a usable nitrogen by the plant. So if I'm looking over here, again, that's going from ammonia inside the soil, and there are some bacteria that are on plant roots that will assimilate it directly into the plant. Now I'm going to come back to what happens here in just a minute. Now let's take a look at ammonia or ammonium. Ammonium is the NH4, ammonia is the NH3. From here, we start breaking it down. Anytime you are breaking down nitrogen compounds into something that's going to be assimilated, we call that nitrification. So from here to here is nitrification. From here to here is nitrification. This part is assimilation. So ammonium will be broken down, or ammonia will be broken down first into nitrites, NO2. It will be broken down by a different set of bacteria into nitrates. Now nitrates can be assimilated or used by the plants. And how do they use it, or how do they assimilate it? They use it in their DNA. So they take nitrates and they use it for more than just their DNA. They can use it for proteins, amino acids, but for us, we're going to keep it simple and just say DNA. Now, something's going to come along and it's going to eat that plant. It's going to break down the plant through digestion, but it's going to use that nitrogen for its own DNA. If pieces of the plants die, they're going to be broken down by decomposers. Now, decomposers, like fungi, bacteria, they will break it down and use it for their own DNA, but eventually it's going to turn into ammonia or ammonium. This thing called ammonification, you don't need to worry about. That's just the technical term for it turning to ammonia. Now this animal, it is going to be consumed by another organism who is going to take the nitrogen in its DNA or its amino acids, and it's going to use it for its own DNA. Eventually you will eat something that has eaten a plant, or maybe you have eaten a plant and have incorporated that nitrogen into your own DNA. This thing will eventually die. It will decompose through decomposers, come back to ammonium, and the cycle will start all again. The other weird one is this one called denitrification. Now there are some bacteria that will take nitrates and will convert it back into atmospheric nitrogen, and then the cycle will continue this way. So if I'm looking at yours, there's a couple weird ones in yours. Okay, so like right here, nitrogen, N2. Electrical storms can take it into the ground where it's going to turn into ammonia. Also volcanic activity right here. Here you have your decomposers that are breaking down dead matter and turning it into ammonia, or waste and converting it into ammonia. And then here, like I said, there's two paths. Ammonia gets broken down by bacteria into nitrite, which another set of bacteria is going to break down into nitrate. It's going to be assimilated into plants, so nitrogen into plants in the form of DNA in our case, eaten by a consumer. That decomposes, or plants decompose, and it goes down this path all over again. Here's the denitrification right here, going from nitrate to nitrite back to a atmospheric gas. Over here, again, we can have bacteria in the air that'll convert it to nitrite and then nitrate. And then this is also nitrification. But this is also nitrification right here. Over here, human activities that contribute to that, nitrogen oxides, or the burning of certain compounds, will add to nitrogen gas. Nitrates in fertilizer will add to our waterways. Down over here, it's basically the same thing, except we're looking at an aquatic system. You have N2 gas. So like you could even just ignore this right here. N2 gas. N2 gas will be taken up by phytoplankton, which use it where? They're living organisms, so they use it in their DNA. Phytoplankton will be consumed by fish, who are going to use that nitrogen for what? For their own DNA. So again, the DNA should be here and travel to here. The fish is going to die or decompose, or it's going to shoot out waste in the form of ammonia. This ammonia will be broken down by bacteria into nitrite. Nitrite will be broken down by bacteria into nitrate. Nitrate will go to nitrogen, and then the cycle will start all over again in an aquatic system. Again, here's another diagram. Again, just be comfortable working with any of them. Again, you have ammonia, NH3, or you could be ammonium, NH4. You have bacteria that's going to break it down. We've talked about nitrosomas before. You don't have to know that for this. Just know that NH3 will break down into nitrite. Nitrite, NO2, will break down into nitrate. From there, it can be used by a plant, and it can be incorporated into its DNA. Now, this one is showing plant protein. Yes, it's using protein and amino acids, but for us, let's keep it simple and say DNA. Now, what happens there? One of two things is going to happen to the plant. It's either going to die and turn into dead organic material, or an animal is going to come and eat it. If an animal comes and eat it, it's going to digest that plant, take that nitrogen, incorporate it into its own DNA. Here it just says animal protein. If the plant dies, it will turn into organic matter. Bacteria decomposers will break it down. It will turn into ammonia again. What about the animals? Again, a couple of things can happen to the animals. Either the animal is going to die this way, or it's going to poop and create waste. Either way, dead organic matter. It's going to be broken down by decomposers, turned into ammonia, and the cycle starts all over again. This one's missing a couple of things, like denitrification. If you remember this one, there are bacteria that will send this all the way back to atmospheric nitrogen. Like this one is missing atmospheric nitrogen. So just be, like I said, any one of these that you look at, you should be okay. Like this right here, denitrification. Right here, this is nitrification. Again, ammonia getting broken down to nitrites, to nitrates, being taken in by plants, being consumed by animals. These two are broken down by decomposers. Decomposers take it back down to ammonia. You should be very comfortable playing with these. All right, here's one more. Again, you'll never find the perfect diagram, but just be comfortable with pieces. Atmospheric nitrogen. It gets into plants, or it gets into the soil. Plant matter dies, or animal waste. Like all these things are connected to one another. Here again, we see nitrates going back into N2 through denitrification. This whole process starting off from the top here at ammonia or ammonium, coming down this way, we call that nitrification. Once it gets to nitrites, it will go back up into the plant. Again, in what form will the plant use it? DNA. From here, it will be consumed by another organism, or it will die. So like right here, plant dying, comes back down, or it's consumed by an organism using its own DNA. This stuff, this nitrogen from animal waste or from dead animals or from dead plants, will be used by decomposers for their own DNA. It'll get broken down into ammonia or ammonium, and it will start all over again.